So I will be talking now for the project IWNet, which is a project that it is, as Nick said, somewhere in the middle between the new projects that they are about resilience and the projects that they are for autonomy, combining aspects of all these components. I am the technical manager of the project, and as a project we are reaching to the end, but we are in the process of getting an extension to the project until this October, which will give the opportunity, first of all, to have demonstrators in a nice kind of weather, especially valuable for river demonstrators that they involve vessels, and also to pile up with some delays that they were there in the project due to the crisis of COVID, and then which have sort of affected the development process of the vessels and some electronics constructions to be integrated in the platform. So as a project, this when from proposal phase is quite back, because it was these two phase proposals. The main intention of the European Commission there was the modal shift to inland waterways, which is as a medium is an environment friendly, potentially medium of transport. And also to sort of combine it with the achievement of certain targets about this modal shift, and the greening also targets of the European Commission in the years coming. As a project, is also mapped to different waterways corridors, and performing different kinds of experiments and tests per specific corridor, and in the values which are generated from the project, we have scenarios like they are city-oriented to urban scenarios, the use of inland waterways vessels to urban scenarios. We have scenarios like the Danube one, which are scenarios that they involve also cross-border, and they are dealing with situations that the waters are low, and how to address all these. And we have a vessel, which is also the waterway that it's things that they improve navigability and the use of the river and the infrastructure are focused. And in the spray, we have the development of accurate vessel positioning, which has been shown in previous projects, how important it is when you are crossing locks where the distances are mattering in a matter of centimeters as regards accuracies. So this sort of a landscape of what are the outputs, which they have been named as modal shift enablers of the project. As a project, the structure was like that. We have a digitalization pillar, and the digitalization pillar involves an architecture that integrates security, blockchain facilitation, information exchanges, sort of integrates IoT and the flow of data through these IoT infrastructure developed, and also integrates the needs to support and much above the supply chain dimension, so to provide something like a complicated composite solution that addresses the end-to-end delivery, especially addressing scenarios at the city level, door-to-door, including even bikes in the whole chain. These information exchanges in the digital aspect are supported by the GS1 standards, so we are standard-based as regards the information exchanges. And this, so far, the digitalization context. In this digitalization, I forgot to say that we have also strategic enablers, which are the development of a library for simulation and models for simulation that they are further used in the second pillar, which second pillar is related to infrastructures and infrastructure development. And how to, in a similar sort of concepts like the ones expressed in Novimove, they relate of how you can sort of make a good use of logs and identify bottlenecks in the river and sort of provide solutions around them. The second pillar also is something that I have not seen presented today, but it's quite important as regards the energy, is the shore power solutions and, that they are provided within this project. And for this one, which involves a composite solution that also is being delivered via for arranging these positions, the booking, etc., automates so the whole process, has also been accredited a patent. The third kind of pillar is sort of developments which they correspond to vessel designs, specific vessel designs that they are addressing either urban scenarios, especially in places that the size matters as regards that the bridges are very low and what is considered small is really small sometimes, and also designs that they are used for cross-border navigation in Danube. And we have also there autonomy solutions that they are quite essential for, especially in when, as they presented in other projects today, we have autonomy solutions, and we have also integrating on these solutions platooning, so you can efficiently sort of use the ability that you can create trains of boats traveling together. And we have accuracy, improved accuracy using satellite Galileo system. And this is the main structure, and which involves these three main pillars. Each one is mapped by a work package, specific work package, and all these, they are rooted to the application scenarios that they are sort of developed within the Living Lab. So in application scenario one, we have the digitalization technologies, and the digitalization technologies include mainly two application scenarios as use cases. The first one is the one that is about the implementation of this synchronomodality supporting solution, which is mapped down to the implementation of a GS1 EPSIS EPCIS compliant system. So it is standard-based information exchanges, and it's about track and tracing, so to have complete visibility of the deliveries, and also supported by NGS IoT sensors specifically for the tracking, and integrated in these end-to-end scenarios. In these end-to-end scenarios, we have Blue Line Logistics, which is participating, and the Port of Brussels and Lille, that they are partners, and it's demonstrated, as I previously said, the hierarchical tracking implemented in IPSIS, integrating IoT sensors, blockchain solutions, supporting, and all these goodies. The second one is the advanced data-driven navigability, so it's called, in uncertain water. And it is implemented by FHO and AIT, who they gather data about Danube, and they have built models that they provide for you, and they give you a visibility of the navigability situation in the river. And also, as a second case, is the design of a specific kind design of vessel based of 48-foot containers to support multimodality that they can be navigated in Danube. The second application scenario is again involving these two other aspects discussed. First of all, it is the infrastructure management and administration, and the logs management, intelligent logs management again, that we have developed by ISL, and working together with ITA Innova, who has developed the simulation library and the models. And these models are specified at higher level definitions and ontologies, so they are usable. And with this scenario is based on a vessel, and this river has had sort of specific characteristics that until Bremen is fully navigable, but there are further down there are issues as regards the vessel numbers. So there is also a study being developed about the area. The second development is, as I said, this port call procedures and the development of the power source solution, which is, it has been run also with a questionnaire to the end users, and it's developing a whole system that's a backend system, and it integrates via IoT all the positions, automatically sort of allocates these positions to the barges that they are approaching, and there is some specific booking also supported by mobile devices. The application scenario 3 involves again two main cases. The first of all is the development of a specific boat type that it is able to navigate in Ghent, which has very low bridges. And this boat, again, with the assistance of a specific box that it's being developed by the University of Louvain. It is, can be chained with other boats as a part of a platooning system, and addresses issues like, for example, it is becoming as a complicated as a full solution more meaningful in terms that you can increase thereby the size without increasing the size of a specific boat. Also, we have the developments of in which are being tested in the express segment by DLR, the controllers that they are linking with the Galileo services for improving the accuracy, and all this is packaged and it's linked to the box of developed by the University of Louvain, so to improve the accuracy. Also, from these kind of developments, there are other interesting outputs, like something coming as the SARE space intelligence, where you can, up in the cloud, provide what is your sensory impression of a place, and collaborate with boats coming to improve, let's say, all these crossing kind of incidents that they are coming. So, this is a bit dense, but this is actually, historically, it's not very much back, but we managed to, after 2 years, have a face-to-face meeting, so we all were together discussing every specific lab, everyone output, and so we came up with many answers. How we align with the NIAID's impacts as they are defined. So starting from smart waterways, we are improving the decision-making to infrastructures. We develop IoT sensors in full visibility, which also they are linked to the commercial aspects of the supply chain, like using GS1 as a standard. Visualization of river data, that this is the work developed by, as I said, the AIT and FHO. The shares intelligence space for sharing intelligence and the situation awareness about specific river points. The simulation tools and the libraries for operation support that they are being developed, and the sharing of standard type of information. Going to shifting freight to water, there are these specific different types of vessels being developed, and we have this Danube kind of designed vessel for improved navigability situation in log streams where the water levels are sometimes quite low. Smart vessels for the city environment, and Galileo for developments for accurate positioning, and to increase reliability in planning and costs, including also the revenue management methodology, which is sort of driving the synchromodality kind of matching of decisions. To the zero emissions, our designs, especially with the vessels, are sort of promoting the use of electrical engines, especially the one that is being developed for the Ghent area. And as regards the attractiveness to the jobs, it is sort of improving, let's say, the content and the specification of required by performing a job, by sort of driving towards the autonomy of the vessels and the automation of the processes. And also we have a component within the project that develops an observatory that gathers information related to inland waterways to inform the public. Yeah, this was IWNet.
Zisis asked me if we had a bigger impact map. I said, no, if I give you a bigger impact map, you keep writing until it's dark.
The arrows are not that many, though, because you wouldn't be...
No, you did well, Zisis, perfectly done. Any questions from in audience? There are so many people who have not opened their mouth yet, except for having coffee and eating lunch.
I find it quite impressive, because you give the impression with the project you are going to realize the complete NIAID's action program. So with regard to really the implementation of the application scenarios, how will that take place so that we really can check the implementation of the NAIADES action program? Thank you. I'm Karin, the Schipper from Inland Navigation Europe, between brackets.
Inland Navigation Europe is Fairway Authorities.
Do I have to say something with that? No.
Yeah.
Yeah.
Yeah, it's you go ahead. The question was asked to you.
The question, but I really didn't get the question. If the application scenario, can you rephrase it?
How this will all be implemented?
How all this implemented? It's all these application scenarios are there. They are running now. So for each application scenario, there is an implementation program to be.
This is not working.
Okay. There is an implementation set of actions for every application scenario to be delivered, and we have for the Living Lab there is some kind of a methodology which defines a step, but we have also the evaluation step at the end that gathers all these kind of results. Now, depending on the difficulty of the implementation, we do not discuss the TR levels 7 or 8 fully, but some of them, they are at the demonstrator kind of, but they are going there to be seen, and they are quite clear, the results that they come out. The dates, yeah, the date is we finish max end of October. Yeah, so we are going to have our demonstrations, as we discussed, they are going to be September, and maybe we have something in June. Yeah, near end of June.
Anybody else?